Masking tape. It is used to bond the materials so that it will not separate, and also to ensure that all materials are securely attached. Yarn. We used it to attach the yarn and the manila paper to help the parachute work. We used yarn to act as its suspension line. The length of the yarn will affect how the parachute works. Therefore, we made sure that the yarns attached and used were equally cut. Manila paper. This will cause the parachute to float. We used it to form our box that will support the egg. It will has less possibility to tear while carrying the egg, that's why we chose to use it. It was attached to the yarn and the box for it will stand as the parachute swing.
Gravity and air resistance explained. An egg drop without anything to slow it down will fall fast and break easily. The parachute add air resistance, slowing the fall and stopping the egg from breaking. We also found that the parachute fell much more slowly. As learned above, the amount of air resistance depends upon the speed of the object. Thus, more massive objects fall faster than less massive objects because they are acted upon by a large force of gravity. For this reason, they accelerate to higher speeds until the air resistance force equals the gravity force.
Air resistance is a force that slows down objects moving through the air. It is also called drag. When an object falls in air, it has to push through the air particles. This causes the object to fall slower. Objects are affected by gravity the same, but air resistance can affect the speed of an object's descent. An object with more surface area will have more air resistance. The more surface area the object has to get through the air particles, the slower it will take to fall. This explains why any force of impact on the protective device can severely damage the egg.
The science behind this experiment is found in Isaac Newton's law of motion. In the first law, it states that an object at rest will stay at rest, and an object in motion will stay in motion. Unless acted upon by an external unbalanced force, this law means if the forces are present on the falling egg are equal, it will remain its current state of motion. If a force is greater than those present on the egg, it will accelerate. If you hold an egg, the forces you are applying are equal and balanced, canceling out the force of gravity. Therefore, it remains motionless in your hands. If you let go, the egg gravity becomes unbalanced force and causes the egg to fall to the ground. In Newton's third law states that for every action there is an equal and opposite reaction. That means when you exert a force on an object, the object will exert a force back on you. Why? It is due to the ground returning a force from the egg as it reaches the ground. By using absorbing material, it can help reduce the amount of forces exchanged between the ground and the egg. In order to decrease the egg's velocity upon impact, we designed a carrier to have an increased air resistance. An increased surface area on the carrier will cause the egg to hit the ground at a lower speed to increase the time over which the egg comes to rest. We provide the eggs with something to absorb some of the force by putting cushion or sponge in the carrier that will keep the egg from stopping in a swift of motion as it hits the ground.
Our biological weapon container was designed like a parachute. The manila paper's wide surface area catches the air, the reason why the parachute slows down. The construction of the device was strong. The materials that we used made our device a success. The reason why it took 3 trials before the egg had small cracks.
So, good morning guys. I made this kind of parachute. So, I used a manila paper where I used it to form the box of our parachute, and then I used this yarn to lessen or support the impact of the egg when we will throw it on the floor. And I use the tape to attach all the manila paper in order to form our box. So this is our finished product.
In conclusions, on the first 1 meter drop, our protective device falls down rapidly because of the distance to the ground, but the result is the egg has no crack. On the second meter drop, our protective device falls down slowly but had a greater impact than the first drop, but the result is the egg has no crack. On the last drop, the second floor of the house, our protective device falls down slower than the second drop and had more impact than the first and second drop, which resulted to the crack on the egg.